or mutates, and a characteristic of the organism.
Seriously? Today we're going to be looking at another one of Veritasium's videos, specifically how Kodak exposed nuclear weapons testing. For those of you who don't know me, I'm Tyler Foltz. I'm a nuclear engineer with a little over 10 years of experience in the commercial nuclear power industry, from engineering operations to emergency response. I don't claim to know everything there is nuclear, but I can certainly share some knowledge. Let's check this out.
There's a place in the New Mexico desert, open to the public for just 2 days out of the year. But I got to visit by myself with only a small film crew.
Like the car.
This is the Trinity bomb test site, where on July 16th, 1945, at exactly 5:29 and 45 seconds in the morning, the first nuclear bomb was exploded.
Appreciate the date precision there.
And the test was called Trinity. There was actually a tower here that stood 100 feet, or about 30 meters. The list of people who witnessed the test reads like a who's who of 20th century physics. Fermi, Feynman, Oppenheimer, von Neumann. But the test was top secret. The general public weren't to know. But how do you hide a huge nuclear explosion?
Well, you put it in the middle of the desert. But yes, this was quite the secret project. For those of you who have watched my previous videos, you're aware of my comments on the weird units in nuclear energy, such as shakes and barns, a shake being 10 nanoseconds, and a barn being 10 to the minus 28 square meters. That came from secret code used on the Manhattan Project. In fact, a lot of the massive amount of resources that were dedicated to the Manhattan Project, most of the people that worked on it didn't know what it was for. Like, I'm not talking about the scientists, I'm talking about logistics coordinators. It's just like, okay, we're going to bring a bunch of secret material to this one site in the middle of nowhere for military research. And that's about as much as they would know about it. Just enough to do their job.
Well, the Albuquerque Tribune published a statement claiming it was a large but accidental conventional explosion. It wasn't just
chemical plant explosion. That's the one that they use in all the horror movies. And it's very dangerous, so we can't let you go past this road. Love it.
The general public, who were kept in the dark. The governor of New Mexico was not even aware that Trinity was a nuclear test until after the bombing of Hiroshima.
Not many people knew what a nuclear test was prior to the atomic bombings. A lot of people probably didn't know what the word nuclear was, who were as far as the general population, especially because back then they used the word atomic when they meant nuclear in a lot of cases. Even though, and of course today we mean nuclear referring on an even smaller scale than the atomic level.
Even then, details about the blast were scarce. But Kodak, the film company based on the other side of the country in New York State, well, they figured out what was happening.
I never knew this story. This is going to be fascinating.
It all started with some defective X-ray film. Kodak found when they developed unused film, it showed 10s or even 100 little dark spots. The film had been exposed to radiation even though it had never been taken out of its packaging.
And yes, nuclear blast would release a lot of gamma rays and X-rays. I mean, gamma rays, of course, are just light, but at an even higher energy level, higher frequency. But they release X-rays as well. Just not a whole lot of people talk about X-rays from nuclear blasts because the gamma rays and the fission products are the vast majority. Yes, the neutrons from the fission are unit for unit over 10 times more radiation when you look at human dose equivalents as far as what it does to the human body, but that part doesn't last very long because the neutrons stop when the reaction stops, and the reaction just lasts a couple of shakes. It's the fission products contaminating the area that are going to do the most radiation release, especially for a ground burst.
This was actually not a new problem. During World War II, radium was used extensively to make glow-in-the-dark dials, flight instruments, and watches. Radium glows because it is radioactive. It gives off alpha particles. Now,
okay, they mentioned in conjunction with a phosphor.
Some of this radium ended up on paper and cardboard at these factories. and because supplies were scarce, leftover paper products were salvaged and recycled, leading small amounts of radium to end up in the general paper supply.
So he says it's an alpha emitter. It's also a very reactive alpha emitter. Uranium is also an alpha emitter, but radium is 1,000,000 times more radioactive than uranium. And that's not counting, it's only one step away from radon gas, because radium-226 decays into radon-222, which is also an alpha particle emitter, and that one is particularly nasty. So the main hazard with alpha particles is internal dose. Most of the alpha particles won't penetrate your skin, which is why uranium's really not that hazardous unless you ingest it or you get particulate matter on your hands and you stick them in your eyes or do something like that. And those radium dials that were often licked in the infamous Radium Girls story, and they would go on to develop throat cancers. It is way worse in terms of what it does to the human body than uranium.
And when this paper was used to package up Kodak film, radiation from radium would expose the film before it was ever used. And it was such a problem that Kodak altered their supply chain, carefully selecting just a few paper mills where they could strictly control the raw materials. One of the mills was in Vincennes, Indiana, on the Wabash River. It made straw board, which was inserted between sheets of X-ray film. Now, for months, this straw board was working perfectly, until a batch, manufactured on August 6, 1945, started to cause spots to appear on the X-ray film. So Julian Webb, a scientist at Kodak, was tasked with solving the problem. So he punched out little holes of straw board behind where the film had been exposed, and then he measured the alpha particles coming off that material. But the level was not appreciably higher than background, and this ruled out radium and the other
That's because alpha particles don't. That's because the cover would block most alpha particles.
naturally occurring isotopes of uranium, thorium, and actinium, all alpha emitters.
Yes.
But when he measured beta radiation, he found significant activity. This matched what he saw on the film.
Now, beta particles have a bit more of a range than alpha particles. They'll go through your skin. Millimeter or two of plastic will stop most of them, but more of those are going to get through.
Radiation penetrated several layers, something beta particles can do, but not alpha. And over a period of months, he measured the half-life of the radioactive substance, finding it was only about 30 days. This half-life, combined with the energy of the beta particles, led Webb to conclude that the radioactive contaminant was most likely cerium-141.
That's a weird one that is less talked about. The main ones, as far as the hazards from nuclear testing are, and really anything that involves uranium-235 fissioning is, now that's a bit of a weird one. The ones most people talk about, because they're the hazardous, are things like cesium-137 or strontium-90, and fission products are a probability function. It's a twin pink curve. A lot of nuclear engineers refer to this as the Dolly Parton curve for scientific reason. So it's not an even split. And cerium-141 is within these peak ranges you see for both uranium-235 and plutonium-239, though a bit less for the latter. And these are the axis on the bottom referring to atomic number. But this is per fission, so you're going to see a lot of all of this stuff because you're using many trillions upon trillions upon trillions of fissions in the event of any nuclear detonation or fission in a nuclear power plant, for that matter, because you're mainly using uranium-235.
An isotope that could only have come from a nuclear fission explosion.
It comes from power plants too, but it's not really one that people talk about much because it doesn't last very long in your used fuel. But I guess back then, nuclear power plants were just, well, they weren't power plants, they were science experiments.
What's more, the same contaminant appeared in paper from another of Kodak's mills, this one hundreds of kilometers away in Tama, Iowa. So how did cerium-141 end up in that straw board? Well, when that first atomic bomb exploded in the New Mexico desert, the plutonium core underwent a fission chain reaction. Plutonium nuclei ripped in two, releasing energy and more neutrons to continue the chain reaction.
I actually like the scaling on this. He's showing the two daughter nuclei aren't the same because, hence the Dolly Parton curve, it is lopsided. That's just the way the physics works based on the geometry of the targets from the neutrons. One thing I will say is, especially since this is plutonium and this is a weapon, so you're going to have a mass engineered in a way to make it go prompt critical. This reaction is unbelievably fast. So we're talking, yes, on the order of shakes, and it's going prompt critical, which is essential to how nuclear weapons operate. You want just prompt neutrons to create a self-sustaining reaction by themselves. Compared to, say, a nuclear power plant, which is known as delayed critical, and delayed neutrons, they're not released immediately. They're released multiple seconds later, so it's a more controlled reaction, because you can't, whether it be manually or from any reactor feedback mechanism, control something that's prompt critical. But in a weapon, that's exactly what you want, because you want it to explode. You want it to release its energy very, very quickly.
But fission is a messy process. It doesn't always split the nucleus into the same products. Instead, hundreds of different nuclei are produced, virtually all of them radioactive. And they are carried up into the stratosphere with the mushroom cloud and dispersed on air currents whichever way the wind blows. In this case, they traveled over 1,000 kilometers, ending up over Iowa and Indiana.
And that is entirely dependent on the weather. So post-nuclear accidents, one emergency response action is to look at weather data, look at which ways the wind is blowing. And this isn't from a nuclear attack. I've never worked in that field, but from a nuclear power plant, it's basically a radioactive plume to decide where it's going to go, to decide what regions need to either evacuate or shelter in place. And you measure the activity of the plume, and you make that decision according to which way the wind's blowing. There are some exceptions to this, such as a rapidly escalating event scenario, which is very unrealistic, but we've still trained on how to do it, where there are certain zones that you would evacuate immediately. But for the most part, any realistic scenario, you're looking at the weather, in addition to measuring dose.
Here, rain captured some of these radioactive particles, causing them to fall out of the sky, hence the term radioactive fallout. This radioactive material ended up in rivers like the ones that run beside the two Kodak paper mills, which used that river water to make their paper. So that's how cerium-141 ended up fogging Kodak's X-ray film and exposing the U.S. nuclear secret.
So interesting that it's cerium-141. Now, it could be that that's because that's the one that they were able to fingerprint. Because you'd also have to be aware of this quickly, because its half-life is 30 days. Now, you'd still detect it after a 7 to 10 half-life. So best case scenario, you basically got a year to figure it out. Otherwise, 7 to 10 half-lives, most radiation protection technicians would say it's gone at that point, to the point where you can't even really detect it very much anymore. But stuff like cesium-137 and strontium-90 is around. So I find it interesting that they detect the weird one.
Now, word of Kodak's detection made it back to scientists at Los Alamos who were intrigued and wanted to know more. A consultant wrote to Webb to find out how much radioactivity per square mile he detected, and the size of the particles which fell, and the half-life of the activity. Although Webb completed his experiments by the end of 1945, he only published them in Physical Review in 1949, and that's because I'm sure he recognized just how sensitive his findings were. After all...
Okay, just looking at the dates. So yeah, August 6, 1945. So yeah, it hasn't even used a half-life yet.
He himself had worked on the Manhattan Project at Berkeley and Oak Ridge using electromagnetic techniques to separate uranium isotopes. What was clear to Kodak was that they needed to take steps to protect their film. And so they installed air samplers to monitor for fallout in the air intakes of their buildings.
Love it. Radiation detectors to protect your film. That's your first priority when doing a radiation detector. I can't say I've ever used a radiation detector for that purpose. Also, I'm fairly young, so I haven't really used film that much.
Fallout is a vitally important subject. Bombs are being tested, which to some extent contaminate the atmosphere.
To some extent.
Now, the U.S. government was aware...
I like that. A lot of how much goes in the atmosphere depends on how high you set off the bomb.
They needed to carefully consider where to test nuclear bombs.
What we need is a site closer to our stateside laboratories and available air support. Somewhere in the continental United States. But where?
After Trinity, the Manhattan Project's chief of radiological safety, Stafford Warren, recommended tests be conducted at least 150 miles from civilian populations. In 1948, an Air Force meteorologist...
I wouldn't want nuclear tests in my backyard, though I don't have any issues living close to a nuclear power plant.
Colonel Holzman told the site selection committee that a location on the East Coast would be best, because otherwise the prevailing westerly winds across the U.S. would spread the fallout across the country. The site they chose was Nevada, almost as far west as you can go and just 100 miles from Las Vegas.
Love it.
The rationale was this site was closer to weapons labs, so it would accelerate their development. After the first bomb test there in...
Speed over safety of the public. That's a very different time period, I guess.
1951, Kodak detected fallout at their headquarters in Rochester, New York. After a snowstorm, Geiger counters read 25 times the normal background. So Kodak threatened to sue the U.S. government for the considerable amount of damage to our products resulting from the Nevada tests or from any further atomic energy tests. But instead of a lawsuit, the two sides came to an agreement. The Atomic Energy Commission would give Kodak, and indeed the entire photographic industry, advanced warning about upcoming tests and where the fallout was likely to end up given meteorological models.
It's fascinating that it's based on messing with film. Now, granted, film is going to be more sensitive than, this film is very sensitive in how it operates, so it's not like we're comparing that to, say, human organs, for instance. If that were the case, then doctors probably wouldn't give you x-rays. But it's just a little different. Different time, I guess.
In return, the company agreed to keep quiet about radioactive fallout. And from 1951 until 1963, the U.S. conducted 100 above-ground nuclear tests in Nevada. The resulting mixture of radioactive nuclei was blown, as predicted, across most of the country.
Oh, okay, so what is this? Rads per capita, iodine 131. So they are measuring it in dose equivalent iodine 131. I don't know if this figure is right, but what's interesting is dose equivalent iodine 131 is still used as a metric for nuclear power plants for off-site doses. And that's because iodine 131 is the most immediately hazardous following a radiological release, because iodine gets in your thyroid and increases your risk of thyroid cancer. That's why potassium iodine tablets can be issued after a nuclear accident by the emergency director to mitigate it, because that is the most immediate threat, not a long-term threat like cesium-137 or strontium-90, but the immediate threat. Now, it only has a half-life of 8 days. Why it's not a concern anymore, like after Chernobyl, for instance, because it's long gone. At least not a concern anymore. It was a massive concern at the time. Now, as far as order of magnitude, so gonna assume kind of beta gamma dose, so I'm gonna assume a rad is a REM in terms of dose equivalents to humanity. I'm not sure the timeline, if this is cumulative upon all of those nuclear weapons testings. That's what I think it is. But the amount of dose, according to the linear threshold model, to which an increase of cancer is evident, is 100 millisieverts. And converting that to this unit of rads would be 10 rads received in 1 year. That also figures out to double the dose limit for radiation workers. So these pink regions, if this is accumulated over 1 year or less, then they're looking at an increased cancer rate. Now, that value is 100 times greater than the US dose limit to a member of the public today. I don't know what it was back then. I don't know if there was one back then.
When these atoms fell on agricultural land, they were eaten by livestock or taken up in crops, and they became part of the food supply. Radioactive iodine 131, eaten by cows, is passed on to humans through their milk. And this is particularly problematic because iodine is concentrated by the body in the thyroid gland. And children with small developing thyroids drink the most milk. It's estimated that the nuclear tests led to tens of thousands of extra cases of thyroid cancer. The atomic energy...
That's possible. I mean, we saw in those regions. Now, children are going to be more sensitive than that 100 millisieverts per year. And we saw some regions. Now, it's hard to fingerprint that without getting samples from everyone, which I know they didn't do back then, especially in all those rural areas. But it is possible to have higher cancer rates, especially in children, because those numbers I referenced were for adults. To give you a sense of scale, for pregnant women, radiation worker doses are decreased. All dose limits are decreased by a factor of 100. Now, fetuses are even more sensitive than children, but that just gives you a sense.
The Commission wasn't too worried about iodine-131 because it has a radioactive half-life of only 8 days. It decays quickly. They were more concerned about strontium-90, which has a half-life of...
That's true, but if you want your milk fresh from the cow after right in the grass, it's possible it's only gone over a couple of half-lives, maybe. I don't actually know how long it takes for something to go from soil to cow to milk. It may take a couple of half-lives worth. I also don't know what the biological half-life of iodine in a cow is, but there's a separate formula for that where you look at the radiological half-life and the biological half-life to figure out how much of it is in the cow and being translated to the milk. So the tens of thousands is probably an overestimate based on that, but I don't know a whole lot about cows.
almost 30 years.
Strontium-90, because of a unique combination of properties, probably represents the greatest danger.
Strontium-90 behaves biochemically like calcium, so when ingested, it ends up in our teeth and bones.
If you eat it, yes, because cesium-137 is a metal.
And as it emits ionizing beta radiation, it can cause bone cancer, cancer in the surrounding tissues, or leukemia. In what's become known as the baby tooth survey, scientists in St. Louis collected up 320,000 teeth between 1950 and 1970. They found that kids born in 1963 had 50 times more strontium in their baby teeth than those born in 1950.
Interesting it being higher in formula than breast, and that just shows that with breast, it's scaled with the biological half-life of the mom.
63 had 50 times more strontium in their baby teeth than those born in 1950.
Presently existing evidence indicates that fallout has caused only a small increase in background radiation and, correspondingly, only a minute increase in mutations.
Wow, listing mutations, but no, the fallout, with those numbers, now, I don't know if it's aggregate or per year, but those it's not going to matter, because it wasn't. Nuclear weapons tests did not last for 100 years. But they're very much exceeding the dose limits to the public, at least what they are today.
In reality, both iodine-131 and strontium-90, plus other radioactive isotopes in the fallout, almost certainly increased rates of cancer. And
maybe it is per year, because the graph he was showed like the year tick up that it was constant, or maybe it showed it accumulating. I can't really tell.
Other diseases in the U.S. population. This is borne out by studies showing correlations between rates of disease and radioactive isotope uptake. The graph shows a peak in 1964, just after the partial nuclear test ban treaty was signed in 1963. It banned nuclear tests in the atmosphere, underwater, and in outer space, leaving only underground tests. A central aim of the treaty was to address growing public concern over the scale of nuclear tests and the resulting radioactive fallout. When the U.S. Senate finally held a hearing on the matter almost 50 years later in 1997, the agreement with Kodak was sharply criticized, especially by Senator Tom Harkin, who said, "The government warned the entire photographic industry and provided maps and forecasts of potential contamination. Where, I ask, were the maps for dairy farmers? Where were the warnings to parents of children?"
Good priority. Go for the film supply rather than the food supply. Wow, that's crazy.
In these areas, the government protected rolls of film, but
it's a bit like reaching out to a hospital saying it might interfere with like your X-ray machines or something like that. If it's that big, it would be insane. Rather than saying, "Oh yeah, people are going to get some dose." It wouldn't be that big, but it's the equivalent of saying something like that rather than prioritizing people.
Not the lives of our kids. There's something wrong with this picture. And I think the main problem was that in the
I get it. There's something wrong with this picture.
40s and 50s, not enough was known about the biological effects of radioactive fallout.
That's definitely
Every
true.
so often a gene changes or mutates, and a characteristic of the organism.
Seriously? If that's what they're teaching, then no wonder they didn't know what they were doing.
Is altered. We do not know the exact process by which mutations occur.
Cancers
Most mutations from acute radiation, so you're not going to get a second head. If anything, you're going to lose body parts due to extreme burns, extreme dose, and cell death.
It took years or even decades to appear, and fallout models predicted a more uniform and therefore less concentrated spread of contaminants. When students in Albany, New York measured 1,000 times background levels after a heavy rainstorm, well, the Atomic Energy Commission...
I can believe 1,000 times, so probably more than... It could even be more than that in some of those regions that showed up, because I can believe 1,000 times more, because some background radiation is fairly low and some it's higher in other regions. That's why all the dose limits are based on artificial radiation exposure, but if you're exceeding what's now the dose limit by a factor of 100, you're going to blow background out of the water.
Report about the event called it an interesting example of a small area of very intense fallout. Now, concerned with alarming people unnecessarily in downwind communities, the Atomic Energy Commission's approach was to limit as much as possible the information that was shared.
That's horrible.
Their conclusion, it seems, was that...
By the way, the Atomic Energy Commission is the precursor to the Nuclear Regulatory Commission.
People are less sensitive to radiation than film is.
So the studies of radioactive fallout remain inconclusive.
What is certain is that 1945 marked the start of a new era. No radioactive fallout before then, and lots after it. And scientists have shown you can use this to detect wine forgeries. Any wine made in the last 75 years will give off distinctive gamma rays from cesium-137, whereas none before that date will. Plus, the level of activity can be used to estimate the vintage, at least between 1952 and 1980.
Wow. I never thought of using radiation detectors to send it. I never thought of sending radiation detectors to wineries. That's interesting.
A similar technique can be used to detect art forgeries because old paint contains no radioactive cesium or strontium. You can even use strontium-90 to determine the age of a skeleton, how long ago that person died, given it's in the past 75 years or so. This technique has been employed.
This is fascinating. It reminds me of that other video where you can detect lead in people because of all the leaded gasoline. Now, this doesn't seem like it was nearly on the same scale as that, but it's interesting to look at the equivalent of the ring within the tree stump.
In dozens of forensic cases where there previously was no reliable method of estimating the year of death if it was within the last 50 years. This method works because while we're alive, we are ingesting strontium-90, something that stops when we die. To this day, we all have some strontium-90 in our bones, albeit at lower levels. It's been about 2 half-lives since the peak of radioactive contamination, so 3/4 of it have decayed, and the rest has dispersed throughout the environment.
That's true, but is right. It doesn't mean it's gone. Again, the 7 to 10 rule of thumb, depending on how conservative your health physics manager is.
So these days, it's no longer much of a health concern. Still, it is there, inside every one of us.
I would say, yeah, with that many decay, it's not, since we saw that we're well below even the threshold for increased risk of cancer from that source, especially if you're looking a couple of half-lives out. So I wouldn't say it is. He's right in saying it's not as cause for concern now.
Signal that can't be covered up or faked. We are of this modern age. In your bones are the literal atomic fragments of atomic bombs that exploded decades ago.
For that matter, we are the stardust from supernovae that exploded billions of years ago. Yet another reason why I support the peaceful use, the smart use of nuclear technology for power plants, but have very differing views on nuclear weapons. Thank you very much for watching. I'll see you next time.